Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapiens Education. So today I am going to discuss about the NCERT solution, and the chapter which we include is moving charges and magnetism, right? So this is a part 2 video. If you want to go through the previous questions, so you can just go to the part 1 video of this chapter. So let's discuss. So till 4.7 I have already covered in a previous section or previous part. So first of all, before solving a problem, first of all we need to understand that what is the question they have called. Question you need to study it or read it properly, right? A closely wound solenoid. So first of all you need to know that what is closely wound solenoid, right? What is closely wound solenoid? So let's draw the draw the diagram of a closely wound solenoid. So let us suppose this is a solenoid. I hope you have understood this one. So this is a closely wound solenoid. So this is little bit closer, okay? And so this is the closely wound solenoid having 80 centimeter length. So length is equal to 80 centimeter or 0.8 meter, right? Has a 5 layers. So 5 layers means there is a several layers. So again it will wind like this, 1 2 layer. Again it will come to third layer like this. Third layer maybe like this, 1 2 3 4, like this only. Fourth layer like this only, like fifth layer. So total number of layers. So layers they have provided you how many layers? 5 layers they have provided you of a winding of 400 turns each. So one layer contains how many turns? Number of turns is how much? 400, right? So the diameter of the solenoid is 1.8, right? And if the current is 8 ampere, estimate the magnitude of B inside the solenoid. So at the center point or inside the solenoid. So let's just write all the data what they have provided you. So length they have provided you as 80 centimeter. So convert it into meter, right? So this will be 0.8 meter. Now they have also provided you 5 layers of winding. 5 layers of winding, and each winding is 400. Each winding is of 400 turns, right? Now total number of turns, if you talk about total number of turns, so this will be equal to 5 into 400. So this will be 2000 turns, right? Now if you talk about the diameter, so diameter they have provided you diameter of the solenoid. So this is the diameter of the solenoid. So diameter of the solenoid they have provided you 1.8 centimeter or 0.018 meter, right? Now what they are asking? They are asking magnetic field strength at the center of the solenoid. So B is equal to mu naught N I divided by L. So mu naught, put the value of mu naught. So this is equal to 4 pi into 10 to the power minus 7 into 2000 into, so 2000 into current is how much? Current they have provided you current of how much? 8 ampere. So we can put here, so they have also provided current of 8 ampere. So put here the value of 8 ampere and divided by length. So length is equal to 0.8 meter. So finally when you calculate it, so you will get the strength of the magnetic field at the center. See, try to understand this. They are asking at the center or central axis. Everywhere you will find uniform magnetic field at the central axis. So if you want to find it, so just pause the video and try to calculate. So I think you will get 2.5 into 10 to the power minus 2 Tesla. So this is the probable correct answer for this one. So I hope you have understood this one. So let's go for next question. Okay. Now this is question number 4.9. First of all, read the question. There is a square coil of a side 10 centimeter. Of a side of 10 centimeter consists of 200 turns. So if you see this one, so this is the square coil and it is of how many turns? 200 turns, right? So it's like if you put it like this, so 3D, so this is one turn, this is one turn, this is one turn, so this is one turn, like this only, right? So this is how many turns? 200 turns, right? 200 turns. I hope you have understood 200 turns. And the carries a current of how many ampere? 12 ampere, right? The coil is suspended vertically and the normal to the plane. So see here, it is suspended vertically, normal to the plane, and the coil makes an angle of 30° with the direction of uniform horizontal magnetic field. So let us suppose this is a uniform magnetic field, that is B. So it is making an angle of how much? It is making an angle of 30°, right? It is making an angle of 30°. So if you tick, so theta is 30°, right? With the direction of uniform horizontal magnetic field, magnitude 0.8 Tesla. So if you observe what is the magnitude of the magnetic field distance, so this is 0.8 Tesla, right? What is the magnitude of the torque experienced by the coil? So definitely they are, see, this coil has been put in such a way that it is making an angle of theta. So definitely a torque will be created. So first of all, let's try to check what data they have provided you, right? So length is how much? 0.1 meter, because they have given you 10 centimeter. And the number of turns they have provided you how much? Number of turns they have provided you 20 turns. And the current in the coil is how much? 12 ampere. 12 ampere. And the theta, that is angle between the magnetic field and the magnetic field and the vector, area vector of the surface. See, let us suppose this is a surface, right? So you need to check this area vector making an angle with the magnetic field, right? So this is how much? Theta is equal to 30°, right? Whenever you want to take any angle, so don't take just simply like this. You have to check area, first of all, area, and you have to find the area vector, and now just take in which direction it is making an angle. So we will always supposed to take a angle with the area vector only, right? Now the strength of the magnetic field, they have provided you 0.8 Tesla, right? 8 Tesla. Okay. Now the thing is that we need to find a torque, right? We need to find a torque. So let's go and find the torque. So for a torque, the formula for the torque is equal to N, that is number of turns, B I A sine theta. Now how to find the area? So area of the square, that is area is equal to L square, that is equal to 0.01 meter square. So we have got area is equal to 0.01 meter square. So put the values now. Now if you put the values in the torque, so N is equal to 20, B is equal to 0.8, into current is how much? 12 ampere, into area is how much? 0.01 meter square, into sine 30°. Sine 30 means half. So when you calculate it, so what amount of a torque is being created? So let us check. So just pause the video and try to solve by your own. So I hope you have got this one. Torque, the unit of torque will be Newton meter, not Newton per meter. So try to understand this one. Newton meter, right? Got it? So I hope you have understood this one. Let's go for next question. The next question itself is two moving coils. So what is moving coil? So this is the moving coil. So this is the coil, this is a magnet, and south pole there is a magnet and there is a moving coil, and there is a winding of the wire. Wires are being wounded and there is an spring constant, right? So what they have given you, the two moving coils M1 and M2 have the following particulars, that is R1, that is resistance 10 ohm, number of turns 30, area A1 is equal to 3.6, magnetic field strength is 0.25. And another coil, similar coil, will have a resistance of 14 ohm. Number of turns will become 42 ohms, 42, sorry. Area is 1.8 into 10 power minus 3, and the magnetic field strength is T. The spring constant, that is K value, for this one as well as this one are identical. Determine the current sensitivity and voltage sensitivity. Before solving this, what data they have provided you, you have to write. So let us suppose there is a two moving coil galvanometer or any meter. So there is M1 and there is a M2, right? So write like this. In M1, what they have provided you, just what they have provided you, you need to write step by step, right? So if you check it, so in M1, they have provided you resistance of R1, that is equal to 10 ohm, and number of turns is equal to 30, and area is equal to 14, sorry, area is equal to area is equal to 3.6 into 10 power minus 3. Area is equal to 3.6 into 10 to the power minus 3 meter square. And the magnetic field strength, that is B1, is equal to how much? B1 is equal to 0.25 Tesla. Now, if you talk about moving coil galvanometer M2, so M2 you can write here R2, that is equal to 14 ohm. Just you compare it. Number of turns, that is N2, is equal to, just increased, that is equal to 42. And area have also, I hope it has, area is equal to 1.8 into 10 to the power minus 3 meter square, yes. And the magnetic field strength, we can see that this is 0.50 Tesla. Now what they are asking, they are asking the ratio of, determine the ratio of current sensitivity, that is IS. So we need to find the current sensitivity. So IS, so let us suppose the current sensitivity for the coil 1, that is I into S1, that is equal to how much? IS1 is equal to N1 B1 A1 by K1. So K1, in place of K1, we are writing K only, because spring constant for both of them are identical. So we are writing this one. If you talk about current sensitivity of the coil 2, so this will be N2 B2 A2 divided by K. So I hope you have understood this one. Just put the values to get the ratio. If you want to find the ratio, so let's go and what to write, N1 B1 K1. So that is, if you want to find a ratio of I current sensitivity of the coil 1 to the current sensitivity of the coil 2, so it will be N1 B1 A1. So this will be N1 B1 A1 divided by K divided by N2 B2 A2 divided by K. So K got cancel out. So this will be N1 B1 A1 divided by N2 B2 A2. So just put the values here. N2, N1, what is the N1? N1 is 30. 30 into A1 is 3.6. Let's 30 into B1 is 0.25 into A1. So A1 is how much? A1 is equal to 3.6 into 10 power minus 3 divided by N2, that is equal to 42. B2 is 0.50 into area is 1.8 into 10 power minus 3. So when this will get cancel out, so This will get cancelled out, so this will get cancelled out, so this is finally 30 by 42, so this is 21. So this ratio itself is coming as 5 by 7, right? Now if you go through the voltage sensitivity, so voltage formula for voltage sensitivity, so voltage sensitivity will be how much? So put the values, first of all, voltage sensitivity, that is Vs1. So this will be how much? Current V is equal to, we know that V is equal to I by R, right? Sorry, IR, right? So it's voltage sensitivity. When you check about voltage sensitivity, so we need to use the formula Vs1. So Vs1 is equal to, write the formula. So Vs1 will be equal to N1B1A1, N1B1A1 divided by K into R, and Vs2 is equal to N2B2A2 divided by KR. Now we need to find the ratio of voltage sensitivity of the coil 1 to the ratio of the voltage sensitivity of the coil 2. Now when you do this one, so what we are getting, KK get cancel out. So this will be N1 B1 A1 into R2 divided by N2 B2 A2. This will be A1, no? This is R1. So just put the values. So N1 is how much? N1 is 30 into 0.25 into area is 3.6 into 10 to the power minus 3 into resistance R1. So how much they have provided you R1? R1 is 10 divided by N2 is how much? N2 is 42 into 0.5, make it 5 into 1.8 into 10 to the power minus 3 into resistance. So resistance they have provided you 14, right? So finally what we have got in earlier, this ratio itself, is1 by is2, that is equal to, I think we have done some sort of mistake while putting the formula. See, the thing is that this is your R2 and this is your R1. So what is the values of R2 here? R2 they have provided you 14. So above should be 14. See, above should be 14 and this one should be 10, right? So let's check it, because when you put a formula, so put it very costly. So this will be 14 and this will be 10. Now see, now it is how much? So this is 5 by 7 into 7 by 5, right? So this will be purely 1, right? So this is the ratio of voltage sensitivity of the coil 1 to the coil 2. And this is the current sensitivity of the coil 1 divided by current sensitivity of the coil 2, right? I hope you have understood this one. So I hope you have understood this question. So let's go for next question. And the next question is, so I hope you have done this one. We have got the ratio of voltage sensitivity. So again, just you try to understand. This is the ratio of voltage sensitivity. Voltage sensitivity. And this is the ratio of current sensitivity. 5 by 7, that is equal to current sensitivity. Right. So let's go for next one. So first of all, read the question. In a chamber of a uniform magnetic field. Chamber, let us suppose there is a chamber, gas chamber like this. So there is a uniform magnetic field. So let us suppose from here we can say that the magnetic field, it is going inside, right? An electron magnetic field has a magnitude of 6.5 G. So let's write the magnitude of the magnetic field. So that is B. They have provided you 6.5 G. So 1 G they have provided you 10 to the power minus 4 Tesla. So 1 G, so 6.5 G means 10 to the power minus 4 Tesla. See here, 1 G is equal to 10 to the power minus 4 Tesla. So 6.5 G is equal to 6.5 into 10 to the power minus 4 Tesla, right? Is maintained. An electron short with a short in the field. Electron short in the field with a speed, that is velocity, they have provided you for this one. Explain why the path of the electron in a circle determines. Explain why the path of the electron is circle. Determine the radius of the circle. See what will happen as soon as, see, as soon as it will try to move like this. So velocity will be like this. But you, due to Fleming's left hand rule, if you study Fleming's left hand rule, so you will find that there is a three things, that is moving electron, that is fast moving motion of the electron in this direction having velocity v, and the magnetic field is in this direction, right? So it means moving electron means it has a current. So current is there, magnetic field is there. So F is equal to BIL, BIL sine 90 degree. So definitely force will be there. So force will act like this. So since theta is 90 degrees, so force will act in this direction when you apply a Fleming's left hand rule. Say magnetic field is in this direction, velocity is in this direction. So definitely force will be like this. So as soon as it will try to apply a force, so what will happen? The electron will try to move, not move in a straight line, so it will try to move in this direction at that same time. Again force will be applied like this. So again force will be applied, so again direction of the movement of the electron will be changed like this. So in this way it will create a circle, right? So I hope you have gone through the theoretical portion. If you don't know, so go through the theoretical portion so that you will understood, right? Now the thing is that what they have provided you, we need to use that, and we need to find the radius, right? So v, speed of the electron, that is velocity is equal to, they have provided you 4.8 into 10 to the power 6 meter per second, right? And the electron charge, since the electron charge is only electron, so we can write here electron is having charge that is equal to 10 to the power minus 19. And they have also provided you, now it's a to 1.5 only, because they have provided you 1.5, right? So charge, mass of the electron, that is they have provided you 9.1 into 10 to the power minus 31, right? Now what will be the amount of force which is acting in this direction? So force F is equal to magnetic force. See why this force is come into the play, because magnetic field is there, current is there. So due to this, magnetic force will be experienced toward the center, and the formula for the magnetic field, you know that Q V B sine theta, right? But the charge here is EVP sine 90 degree, right? And sine 90 degree, because all are perpendicular, so V, velocity and magnetic field, both are perpendicular, so we can write like this, EVB only. So this is the force, and this force can be encountered, or this force can be rewritten as a centripetal force. Why? Because due to this force only, the electron will start creating a circular motion. So what will be the formula for the circular motion? So this is equal to mv square by radius of the circle. Now equation, we have got one equation, this one, to second equation, this one. So equate 1 and 2. So when you equate 1 and 2, so what we will have? We have EVB, that is equal to mv square by r. Now from here we can get radius of the circle as mv by mv by EB, right? Now put the values, because V is EB. So V got cancelled. This side there is a V. So now put the values. When you put the values, so let's put the values to find out the radius. So radius is equal to what we have found. Radius is equal to m, that is mass of electron, into velocity of the electron divided by electron into B, and sine 90, that is we know. So this will be 9.1 into 10 to the power minus 31 into 4.8 into 10 power 6, because we have velocity 4.8 into 10 power 6, 4.8 into 10 power 6 divided by EB. EB is given, electron charge is 1.5 into 10 power minus 19 into 6.5. So magnetic field is how much? 6.5 into 10 to the power minus 4. Now just you need to calculate. Pause the video and you will get the radius. Radius will be equal to 4.2 into 10 to the power minus 2 meter, right? Or you can easily convert it into centimeter. So I hope you have understood this question. So it is very easy question, or you can also derive it properly, right? Got it? So this is the radius. This is the radius. Got it? Now, is there any part they have left? No. Okay. Now, see, in question number 4.12, in exercise 4.11, obtain the frequency of the revolution. So in the same question, so what we have? We have circular path having a radius r, right? So they are asking frequency. So just you apply your logic. Frequency, that is equal to 1 by time period. 1 by time period. So if you know the time period, so its reverse will be frequency. So time period is equal to total distance traveled in one complete circular motion, that is equal to 2 pi r divided by velocity. Now the frequency, if you put the value of frequency, so frequency will become reverse, that is equal to v by 2 pi r. Now the thing is that we have understood that what is the value of r. So just put the value of r. So v divided by 2 pi into r is equal to mv and by eb. So vb got cancelled. So we will have eb divided by 2 pi m. Now if you find, if you put the values, that is equal to 1.5 into 10 to the power minus 6 into magnetic field. Value of magnetic field is 6.5 into 10 to the power minus 4 divided by 2 into pi into mass. Mass of the electron is 9.1 into 10 to the power minus 31. So just calculate it. So when you calculate it, so I think you will get 1.82 into 10 to the power 6 hertz. But try to calculate it by yourself. Don't rely on my calculation. There may be a error. There may be a possibility, because I am a human, so I may do mistake. But try to complete by your own, right? So I want you to do the calculation. Don't rely on teachers' calculation, right? So I hope you have understood this one. So this is for solution for the 4.12. Now let's go for the solution for the 4.13 question. What is that? First of all, read the question. Read this question. A circular coil of 30 tons. How many tons? 30 tons. So n they have provided you. And radius is how much? 8 centimeter, carrying a current of 6 ampere, suspended vertically. So it has been suspended vertically, right? With the uniform horizontal magnetic field of 1 Tesla. The field lines of the makes an angle of 60-degree with the normal to the coil. So this is the normal to the coil and this is the field line. So if you put like this, this is a magnetic field. So there is a uniform magnetic field and this is the normal to the coil and this is making an angle of how much? 60-degree, right? Calculate the magnitude of the counter torque that must be applied to prevent the coil from turning. So see, we need to find out the torque. So first of all, what they have given you. So n is the number of turns. So that is equal to 30, 30, and r radius of the radius is how much? So this is 8 centimeter means 0.08 meter. So always try to write all the things in a standard one. So if you want to find out area of the coil, so this will be pi r square. So this will be pi into 0.08 whole square. So calculate it. So I think if you will calculate it, so it will come like 0.0201 meter square, right? Now the current, amount of current, that is I is equal to 6 ampere, right? So magnetic field B they have provided you, that is 1 Tesla. And one more thing they have provided you, that is equal to angle. So angle theta is equal to 60-degree. Now what they are asking, so what is the amount of counter torque? See, when there is an angle, so torque will be created. Now how much torque will be required to prevent it from turning? Why? Because it will create a turning moment, and due to which what will happen, it will try to turn. But I want to stop this. So equal amount of torque will be applied on this one so that we can stop it, right? So how much torque we need to apply? So let's put like this torque. So torque is equal to NIBA sine theta. Ni BA sine theta. So this torque is NIBA sine theta. So put the values now. Torque, counter torque required is equal to N is equal to 30 into current is equal to 6 ampere. Ampere. We should remove this one unit so that calculation will be easier one. So current, we have put current. Magnetic field 1 Tesla. Area of the cross section is 0.02101 into sine 60. So sine 60 means root 3 by 2, I hope. So when you put this one, so you will get approximately torque is equal to 3.133 Newton meter. So this is the amount of torque which is being required so that you can stop it from turning. Otherwise what will happen? A torque will be created and this coil will try to turn it out. Now the thing is that what would you answer the changes if the circular coil were replaced by a planar coil of some irregular shape that encloses the same area? So let us suppose we have already seen that the the formula for the torque is equal to NIPA sine theta. Now they are taking that area is constant. So from here what we can infer that it does not depend upon shape, right? So our answer should be no. No, torque will remain same. Remain same irrespective of its shape. So I hope you have understood this one. So we have done this question. So this is question number 4.13. So I hope you have ended up this chapter. So I will come up with the next video for the next, that is magnetic matter. So for continuous videos and continuous solution, just watch and subscribe our channel. Thank you for watching my channel.